So here we are in the file, the Lake Okeechobee file that has a month, day, and year. I'm going to do a regular expression search and replace to eliminate these three fields, combine them into one to make it date. So to start off with, I'm just going to go ahead and change the header to date and create a search and replace field. So with a regular expression, what I'm looking for is a quote and then a number from 0 to 9, multiple occurrences of that. That'll take care of the month. And then a quote, comma, quote, same thing for the day, quote, comma, quote, same thing for the year. And I'm going to replace it with the occurrence of the day is the first parameter, slash the second parameter is the month, the day, the year. So I'll go ahead and check on regular expression, let this fly, check the replacements to begin with, and then just say all, and it's working its way down the 6.3 million line file. I want to pause for a moment until that finishes and come back when it's done. So the process completed in under a minute. You can see the dates are properly formatted. We also have this field in here called blank, which doesn't do anything for us. So I'm going to go ahead and get rid of that because no reason to send that to Tableau. Will be a null field. So let's go ahead and do a search and replace on comma, double quote, comma, and just replace that with a comma. Take care of all those. Pause until it's finished. That just took a few seconds also. I'm going to save the file, and I'll just leave the location data as a string in here, so because there's a comma in there. Otherwise, if I took these quotes off, this comma, I could break this into row, comma, column, but because I'm going to do a lookup, I'm going to do a join in Tableau on this field, I'll just leave it the way it is. And so for now, I'm just going to pause and we'll go over to Tableau and get to work. So now I've just copied the Lake Okeechobee easting and northing coordinates by the row, comma, column, node location, and I'm going to save these as a CSV file so that I can do data blending in Tableau with this file. So we'll save it as a comma delimited file, and I'll call it location. I'll call it node location. Save that, yes, yes. Close the file out, and we'll go have a look at that file. So now I'll be able to do data blending with the key field location here and be able to pull the easting and northing into Tableau. So let's go ahead and load the file in Tableau. We'll get rid of this one because it's a huge file. Connect to data. Not Excel. Connect to connect to a text file. Lake Okeechobee. And first pull in the 6 million line file. I'm going to pause until that's finished. Okay, so the 6.3 million line files in Tableau now. We've got a date starting in 1895 and going forward. We've got location, and we've got rainfall. So that right there tells us for example, just looking at this summation at that location in 1895, there's 42 inches of rain. You can see basically that in 1895, because you're integrating over the whole area of the pond, I mean the lake Okeechobee, that the rainfall varies somewhat because it's a very large lake. It's varying by a couple of inches of rain over the 175 points that are discretized over the entire pond area. So this shows us a summation of all the rain. 42 inches in 1895. Let's see where we are now. 45 inches in 1993. Of course, it's still 20 years ago. But let's do a quick analysis of the rainfall. Let's see. Let's add the rainfall to the sheet. Let's add the date to the sheet. And so we've got summation of rainfall over time. That's what it looks like. Of course, that's all the nodal points. But what I would like to do is show a quick filter of this. Let's make rainfall. Let's see, I got to think about this for a second, what I want to show. I'm going to take a pause and figure something out. Okay, so all I did here was I just put a quick filter on location, and rather than using all the individual points, let's just use the average over the whole pond. Turn those off, turn the average on, and this is what the average rainfall looks like over time for the last 99 years. We had a high of almost 70 inches of rain over the pond area, over the lake area, and low of 32. Now this is using annual data. Of course, if we're really serious about it and we wanted to look at daily data, boom baby, there it is. 1895 to 1993, the maximum daily rainfall 4.2 inches. Of course, the minimum is going to be 0, but that's pretty interesting, the information there. Let's do a little bit further analysis on this. Let's see. Take a pause and think about this for a second. So I've removed the date from the analysis. Let's do a histogram of rainfall. Let's take a look at edit the bin of rainfall. Size of the bins being 1. Let's put the size of the bins as being 0.1. Okay. Of course, this isn't too interesting because it shows you most of the days have 0 rainfall. What I was really looking for was trying to find out yeah, I guess that makes sense. I was looking for the highs. There's the 4 point something inches of rain in a day. Of course, it's a lot of rain. So the histogram doesn't lead us anywhere. So I'm going to take a pause and think about something else. So I've just duplicated the daily rain sheet just out of curiosity. I was going to do a day of the week analysis on this just to see, does rain actually happen any more on one day than another? And so let's take the average. So actually on Saturday is get the highest average rainfall. Of course, that's when people have time off of work, and so rainy weekends are rainy. Saturday's the highest, followed by Sunday. Not quite Sunday, because Thursday's a little higher than Sunday, but that's just an interesting chart to show just what we thought. Weekends are the rainiest days. Also, look at convert that to, let's take a look at the month. How does the rainy season occur in Florida? So of course the lowest rain happens in January and December. The high happens here in June. So May and June, July, August, September, and October, highest rainy days. So we got 1, 2, 3, 4, 5, 6 rainy months and 6 sort of lower rainy months of less rain, January through April and November and December. So that's kind of nice. You get 6 rainy months and 6 less rainy months. I guess maybe that's why a lot of people go there for a vacation. In the summer months, I'm going to pause and take a think about something else. So now I want to pull in the location data and see if we can create a map or an animation of rainfall over the lake over time. So let's make this multiple tables, and let's add a table. It'll come from node location, and let's see, let's add our join command. So Lake Okeechobee location is equal to node location. That'll work. Say OK, and that data extract is active, so we need to regenerate it. I'm going to pause while that happens. So I set up a graph here showing the discretized nodal positions, and the date is the page shelf. It's January 1895. This would be total monthly rainfall in inches over Lake Okeechobee. I've limited the size of the dots to be anything greater than or equal to 10 inches for that month, but the actual maximum monthly total is 23. So I'm going to just animate this shortly, let this run through, and you can see the months are ticking by. This is a 99-year record. Of course, there's 12 months per year, so you're talking 100 times 12 roughly, 1,200 of these animations. I'm going to scan forward. I'm going to stop it here, scan forward into the 1980s and let that animate. But basically you could get an idea of this is what an animation would look like. Of course here the size dots are pretty much uniform because of the methodology of interpolation of the rainfall onto this nodal set. There is some variation in it, but so therefore this animation isn't necessarily that great, but conceptually you can imagine that if you did have variation across this, it would be very interesting. If this were, for example, the United States, and you're looking at sales across the entire country, and these things were changing, then you can animate that and create a PDF of that output automatically. Of course, this would be 1,200 pages of PDF if I wanted to create that, and that would be a fairly large file, probably several hundred megabytes big. But again, this is just to show you what's possible with Tableau.